All right, we're gonna be on 15.5 for this one. Yeah. It's called Rationalizing Denominators, which is just a fancy way of how to simplify fractions with radicals in them. Yeah, definitely back to fraction. So 8 divided by the square root of 5. And you're going to be asked to rationalize this. What happens here is we cannot have radicals on the denominator. So we have to move them back to the top. The way we do that is with square roots, it's relatively really easy. Just take the square root that you see and multiply it by its exact same guy. Now, the reason we do that is what did we just learn that two radicals that are exactly the same, what's it going to become? The number without the radical sign. I now got rid of the radical. But what we've learned with fractions, if I do it to the bottom, gotta do it to the top. Now, can I actually physically multiply these two guys? No, because one is a radical and one is not. So therefore, I would just write it as 8 square root of 5. Now, here's the next thing that students try to do. Y'all try to cancel the fives. You can't. This is a regular 5. This is a square root of 5. So that would be the answer. If you could, yes. If it was like 10 over 5, then yes, you would want to simplify. 8 over 5 can't go any further. That's it. The goal was to get the radical from the bottom. It's a very good point for now. It is. I'm not gonna lie to you. That's a great question. That's a great question. It makes me feel like the our system is a little bit broken because really and truly, unless you're going to be like a STEMs major, which is science, technology, engineering, mathematics, or statistics, you truly will never see this again. Like, so I'm right there with you, but our degrees say that you have to have these things. So, and really and truly, I want to be honest with you, I've always felt that universities and colleges is just a business. It is. It's like, hey, you want this job? You need this paper. You want this paper? You gotta go pay for all of these classes to get it. Like, that's my thing. Like, so just go on my little soapbox here. Like, I become the assistant principal, but I don't have the certificate. So now I have to go pay to get the certificate, even though I'm doing the job already. And it's so dumb, but it is what it is. But I can guarantee you, this certificate I'm going to get ain't going to make me better at the job. I'm going to be just as good as I was before I had the certificate. Yeah. Yep. That's right. Mhm. Like you got the degree, you're making all the money. Why are you asking me what to do? You should be telling me what to do. I used to do cabinet work. I was a foreman, not foreman, apprentice for 3 years. I thought that's the direction I wanted to go. I learned blue collar work. It's not for me. I like AC. It's cold during the winter. It's hot during the summer. There's no in between. Like you're just miserable. Oh, I got things that are occupying my mind just fine inside of a building. I guarantee you. Oh, I can tell you this. So far, in 3 days that I've had this position, I have probably sat at my desk for a total of 30 minutes in the last 3 days because I am running constantly. And I'm like, gosh, especially high school. Yep. So what are we gonna do with this? Perfect. Very good. That's it. Winner, winner, chicken dinner. I'll try this one. So that was like level one. Let's go to level two. You think our approach will be on something like this? What? 999. You just are trying to move the radical. So I'm just going to multiply the square root of 3. Regardless of there being more attached to it, it's the radical that I can't have there. Very good. The square root of 3 times the square root of 3 would turn into a 3, but then you do still have that 9. So that would become 9 times 3. So this right. So you understand why we multiply by the square root of 3 to this point. So I just well, first step. Do you understand why we multiplied by a square root of 3? Okay. So these two guys right here multiplied together produced this 3, but the 9 is still there. So now it becomes 9 times 3. So earlier, when we were multiplying by just the radical, it just became itself, but there was nothing there to multiply it with. Now I have something that's being multiplied to that square root of 3. So when I multiply it by another square root of 3, it's still going to be 9 times, but instead of a square root of 3, it's just a 3, which gives us a nice clean number of what? 27. And then what happens on top? There you go. Again, simplify if you can, but 4 doesn't go into 27. That's level 2. Ready for level 3? We're not we're not trying to play Mario. We're not skipping levels. We're gonna go through path by path, even though we all know where the secret bush is to go to like level 15 or 5 or it was level 5, right? From it was like 1-4 got you to 5-5. Like there was like a little level there. Still remember it. Is that 8-1? That's it. That's what it was. That's what it was. Oop. What do you think our approach on something like this would be? Okay, perfect. Because it's the one on the bottom that I can't have. The one on top is perfectly fine. Correct. Is that what's on top? Now we haven't had a situation yet because square root of 5 was prime, y is a letter, and 3 is prime. But 198, we need to simplify. Which one? The 198? 11 times 18. Because now I'm back to the rules from earlier. Indexes are the same, so I can multiply those. Hmm. Which gave me 18. Or technically, what's 18 times 18? 260, 256? No, 296. No, two. That was way off. It won't. What two numbers? What about 18? Okay. There you there you go. So I can take the threes out. So how's that gonna look? Correct. There you go. And then simplify the fraction if you can. Does 3 go into 18? 6 times. So 3 will go away, and then this will become a 6. So square root of 22 over 6. Again, caution yourself. I cannot simplify these guys because one's in a radical, one is not. So that'd be the answer. Do you have a question? Oh, after we did the factor tree, I had a group of threes, so that came out. And then I had a 2 and 11 left over. So 2 times 11 would give me 22. The 3 and 18, because they were both outside of a radical. Correct. When you have multiple leftovers, we multiply them. Hmm? 9? 6. 3 goes into 18 6 times. Because I simplified this fraction, 3 over 18. We haven't had a chance to do that yet, but we're always checking. In this case, 3 over 18 actually simplifies down to 1/6, but we don't actually need to write the 1. So instead, what I did, I was like, well, 3 goes into 18 6 times, so now the 3 goes away. Or if you look at it as this approach as well, technically, I divided both of these by 3. This one, I got a 1, but I didn't need to write it. Okay with that? All right. Let's look at one like this. This is where rationalizing can get difficult if you don't understand our groups. So the reason we're able to multiply it by its exact self is because how many of the same number do I need in a square root to be able to come out as 1? Well, 2 of them, and it becomes 1. So these 2 5s gave me 1 5. Because if I was to multiply these, I would get 25, which is 5 and 5, and that's why it becomes a single 1. That works really nice with square roots. But not so nice with cube roots. I can't simply just multiply this by the cube root of 7, because how many 7s then would I have? 2. But how many do you need in a set in a cube root? 3. So I actually need the cube root of 7 times 7, so that I now have 3 of the same numbers. But what I do to one side or the bottom, I have to do to the top. All right. So now what is 7 times 7? So we can change this up and just say 4 cube root of 49. And then now that I have 3 7s, all of this will turn into what? Just a 7. Oh, it's a cube root. I'm not trying to hide it, just kind of blending it with my radical. No, the 2 in a square root is imaginary, but the 3 isn't. It's a represents the cube root. All right, let's look at this one. 5 over the cube root of 9x to the fifth. All right. So I need to have a set of 3. 7 was prime at the time. Here's what I suggest to do with problems like this. Start the factor tree. What does 9 break into? 3 and 3. Can I go any further? Well, how many more 3s then would I need to make it a set? 1 more. So it wouldn't be 2 more 9s. It's actually just 1 more 3. Now, this is x to the fifth, but I need this to be a number that's divisible by 3 so it can go into it evenly. So how many more x's do I need to make this number divisible by 3? 1 more, because then it'll become x to the 6th power. Very good. So in this case, I'm not multiplying by the exact same thing. I have to figure out what do I need to multiply it so it becomes nice and perfect. All right. Very good. Now I'll write this out. Oh, almost good. I have now a set of 3s. So that becomes 1 single 3. But x to the 5th times x will become what? So that becomes x to the 6th. And then now, from Monday, I take that index and I divide that exponent. So what's 6 divided by 3? 2. Good. So then I get a nice clean 3x squared, no more radical. So what's going to be on top? The 5, but yeah. Good. And again, the cube root of 3x, yeah. And again, you cannot cancel these 3's and these x's because this is in a radical. This is not. All right, you're ready for the boss? We'll do a little mini boss. All right. Here's where all of your skills from chapter 14 now come into play. You're now going to be Oh, yeah, if you haven't, yeah, we're started at 14 yet. All right. It's going to be a busy weekend for all of us. But just think, there's only 2 more weeks. Yeah. Just know, like, after your final exam that Monday, you can crash the rest of the week. Be like, well, it is what it is at this point. Yes. Looking forward to that. All right. In this situation right here, you have the square root of 3 minus 5. To get rid of this radical, I don't think it's from the previous section, which I think we only did one. Actually, I don't even think we did see one. You saw one on the very last question. I'm going to randomly bring this one up. This was your last question, right? And I asked you to type that in the calculator, and you got 7. Here's why you got 7. These binomials are exactly the same. The only difference is you have a minus and a plus. When that happens, all I have to do is multiply the first and the last. So square root of 8 times square root of 8 is what? Just 8. And -1 times a +1 is what? And 8 minus 1 is 7. So using that concept, we're going to do the same thing here. Because notice, I just multiplied two things with a radical. My final answer did not have a radical, which is what I want. I don't want no more radicals on my denominator. So what I want to do, when you're faced with this situation, you're going to multiply this binomial by its exact self. You're just going to change the sign in the middle. So now I'm going to multiply by the square root of 3 plus 5. And of course, what I do to the bottom, I must do to the top. Add? Oh, gotcha. Okay. So because these are the same, I'm just going to multiply the firsts. So square root of 3 times square root of 3 is 3. -5 times +5 is we're multiplying. -5 times 5. What's 5 times 5? And then a negative and a positive would make a -25. Because the 3 was there. And then what's 3 minus what? Timesing, yeah. So this is that full part. I'm doing the first and the last only. So it'd be -22. But I'm left now with the number that's not a radical. But I still have the work to do up here. So just like in the previous section, I need to distribute this. So it's 5 times square root of 3. Remember, this is not in a radical. This is in a radical. So I have to write it as such. I can't actually multiply them. But 5 times 5, I can multiply, which is 25. And you can't combine, and then they all have to have the same number in common. So in this case, no. But you do always want to check that because you don't hate to do all the work and then get it wrong because yeah, simplify. All right, so that was actually part A. Oh, sorry. This step right here skipped over here. This one needed 2 steps. This one just had 1. All right, so let's try 15 over 3 plus 2 square root of 6. It's connected to a binomial now. You cannot. One has a radical, one does not. Perfect. It would. So I'm going to do 3 times 3, which is 9. And then now when I do this part, it's 2 squared to 6 times -2 squared to 6. I want to remind you of this problem right here. So the radical became just that number, but I still had to multiply by any number on the outside. So a positive and a negative make a what? Negative. So take care of that for yourself. And then 2 times 2 times square root of 6 times square root of 6. 6. Very good. 4 times 6, 24. Mm-hmm. And then 9 minus 24. I do. All right. Now, this is going to be hard to notice. So you could technically distribute all of this, or notice that there's a 15 here and a 15 here. All right. So if you go back to chapter 14, if you haven't seen it yet, when you are multiplying rational expressions, if it's on one side or the other, I can cancel them. All right. So this 15 will cancel this 15. No, it's just one's on top of the fraction, one's on bottom of the fraction. So technically, let me rewrite all this. This is technically what's over here. If I don't distribute, this is what I still have left on top. So then the 15s would cancel. And then I still got this negative. Hold on, I wrote it down earlier. Your homework wrote it. Yeah. So they took that negative right there and they actually distributed it. So it looks like this. Negative 3 minus 2 square roots of 6. So then what they did is they took the negative from the bottom, brought it to the top, and then they distributed it out. So that gives me negative 3 plus 2 square roots of 6. Now, if you didn't notice it, you could have still distributed it, and it would look like this. So alternatively, we'll do it in red. I could have done 15 times 3, which is 45. 15 times 2, which is 30. And when I got to this point here, so alternatively, I would have had 45 minus 30 square root of 6 over negative 15. And we always want to make sure we're simplifying. So 45, 30, and 15 all have 15 in common. So then I would divide by 15 on top and bottom. And when I do that, 45 divided by 15 is 3. 30 divided by 15 is 2. Can't do anything with that radical. And then 15 divided by 15 would be negative 1. All right. And then that negative would basically just change all the signs. And you get to the same conclusion. So if you notice it, it's great. It's less work you have to do. But what happens a lot of times with students is they get in the grind and they're like, all right, this is the process. And and then they get to this answer. Do that a few times and you realize I need to check before I do all this work, especially with larger numbers to see, hey, can I have simplified this before I made this process a lot bigger than it needed to be? And I can tell you to do that, but you won't do that until you've done it about 4 or 5 times. And you're like, all right, that was too much. I get it now. But you have to go through that process. I can't tell you not to do it because you're going to do it anyways. And it's not because you don't want to. Obviously, you want to do the easier way or the simplified way, but your brain is going to start with, this is what I know to do. And it's okay. And that will give you the same process. All right. Yep. I'll write out the next one. All righty. What is our approach? Okay, it's not a bad approach, but both of them are technically attached to each other because of the plus sign. So technically, this is a binomial. How do I rationalize binomials? There it is. You take the exact same thing you already have and just change the sign in the middle. Watch out for that. You can't actually subtract them. So you have to leave it as is. All right. And then because they are the same with different signs, I can just multiply the first and multiply the last. So square root of 8 times square root of 8 is 8. Square root of 3 times negative square root of 3 would be negative 3. And then now 8 minus 3 gives me, no, in this case, you would be subtracting, always subtracting. I don't know if you have noticed that, but it'll always be a subtraction. Be 5. And then 1 times this is just going to be what? That's just going to be itself, right? But do watch out for that. 8 minus 3, yes, I can get 5. Square root of 8 minus 3 or square root of 3, I cannot combine those. Right? Let's try 8 over 1 minus square root of z. I think I'm going to let you try. Sounds good. Let's check it. What am I going to multiply by? All right. 1 times 1. Negative square root of z times square root of z. Perfect. And then what would I do here? Okay. Very good. There you go. Take it in. When I distribute it here, so 8 times 1 is 8, and then 8 times square root of z is 8 square root of z. All right. So let's try another one. Let's look at E. This one's a little bit different, so leveling up here. X plus Y over the square root of X plus the square root of Y. What's your approach? What do you mean by that? Perfect. That's it. So that becomes square root of X minus square root of Y. That's square root of X times square root of X is X. And square root of Y times negative square root of Y is negative Y. I forget how the homework went on this. Kind of. This is where it gets complicated. If it wasn't already complicated. It wants you to FOIL this or box method, however you want it. This is where I start feeling like FOIL comes in a little bit better because it's a little bit less work, but box method, you'd have to do some side work, then bring the result over here. Either way works for me. X times square root of X would be X times negative square root of Y. Y times square root of X. Y times negative square root of Y. And there's your answer.
Yeah.
This top part here, yeah, the whole problem from the beginning. So it's the same process as before. I take my binomial. I'm going to multiply by the exact same binomial, just with a minus sign. And then I multiply the first. So x times square root of x times square root of x is just x. Square root of y times negative square root of y is negative y. We okay with that bottom part? That bottom part we've done on every problem so far. Okay, this next part, totally understandable. If FOIL is not your thing, box method works. You would have x and a y, and a square root of x, and a negative square root of y. X times square root of x, one's in a radical, one's not. So I can't actually multiply those. So I have to write them as is. Y times square root of x, same process. One's a radical, one's not. So I have to write it as is. X times negative square root of y, again, same process. One's a radical, one's not. So it becomes negative x square root of y. So I basically have to write it as is. Y times negative square root of y, once again, we want to try to cancel those square roots because, oh, they're the same, but one's a radical, one's not. I can't actually physically cancel them. So it becomes negative y square root of y. And then in this situation, nothing combines. So you would have to write this one, then you can write this one, and then you can write this one, and then you write this one. Any order you want, actually. Yeah, so I could have gone top to bottom, back to top to bottom. I could have gone a circle. I could have gone a backwards circle, C, whatever you wanted to do. Doesn't matter. Because again, at the end of the day, if this was 2 plus 3 plus 4 plus 5, that'd be the same thing as 5 plus 4 plus 3 plus 2. Mm-hmm. I'm going to give y'all one to try. 11 over 8 minus square root of 3. Square root. You're good. You're good. You're good. You're good. You're good. There you go. I'm almost positive 61 is a prime number. If you could, but you can't. Well, I'm gonna just go off with 11 being the smallest number doesn't go into 61, so I'm going with that. I'm almost positive 61 is a prime number though. All right. Now I do it. That's right. That's perfect. I got it. Fine. Now, I'm not going to be able to finish 15.6, but I definitely want to go ahead and start 15.6. So, and I say that because we only got 12 minutes. I would have given us a break, but I need to show you some of this just in, just in case. Yeah, I don't go watch my videos later. That will be posted. I have them posted. I will, I promise. Ah. All right. So solving radical equations. So now what we're going to do is take everything that we've done so far in chapter 15, and now we're going to solve for our x, just like we did with all the rest of our different functions. So this is also where chapter 13 is going to come into play when our with our quadratics and our factoring and stuff like that. That's where this will come into a big play. So if you got that down from the last test, it's coming again on this test. There you go. So here we go. So you're going to see problems like this. Square root of x squared minus 48 equals 4. Now, just like just like any other operation that we have, what is the opposite of multiplying? What's the opposite of dividing? What's the opposite of adding? What's the opposite of subtracting? What's the opposite of square rooting? What kind of exponent? Square. So the opposite of a square root is a square. So square root is an operation of math. So if I don't want to have a square root, I need to square it, right? But we've learned with equations, what I do to one side, I have to come over here and do it to the other side. So if I'm squaring this side, I'm going to square this side. Now I say opposite operation because we've learned now two square roots that are exactly the same being multiplied together will basically cancel the radical. So that's what's happening here. This square root and this square cancel each other out. And I'm left with what's inside the radical, which in this case is now x squared minus 48. So our first objective is to get the radical by itself. Now, in this case, it already was. Our second objective is to get rid of that radical because I don't want to solve it because I don't like it. I don't like that radical. I'm going to get rid of it. And I'm going to do that by either squaring it, cube rooting it, or sorry, cubing it, fourth rooting it, all kinds of different things. I don't think they do cube roots for y'all. I mean, it goes infinitely. And I think on, yep, there is. The very last question of y'all's homework has a cube root. But you would just cube it. So now let's finish this problem off like you did in chapter 13. Well, 4 squared would be 16. All right. Did, Mm-hmm. And your two parentheses, right? Because you're trying to factor. Let's go with that. Do you remember my first step before we could factor? What do we have to do with our quadratics? Now, this is chapter 13. You're on a good approach. I think you actually said it earlier. What do I have to do before I can factor this? Set it equal to 0. How do I set this equal to 0? Minus 16. Ooh, negative 48 minus 16. I will say when I was doing it in my head though, I did go to 32 too. I was like, man, 32 is gonna be a rough number. And I was like, oh, it's two negatives. So I did the same thing in my head. All right, so what was it? 64? Perfect. Now, if y'all recall, when it's a binomial squared, remember that, and I think this is all over chapter 14 as well. But this we learned this in chapter 13. I'm trying to multiply to negative 64 and add to 0. And if you recall from both chapter 13 and 14, if I'm adding to 0, that tells me that it has to be two numbers that are exactly the same. What two numbers make 64 that are exactly the same? 8 and 8. But to make it a negative, only one of them will be negative. So when I open up my two binomials, because that's what every quadratic will factor into with the leading term of x, one will be a positive 8, the other one will be a negative 8. At this point, this was towards the end of chapter 13, what did I then have to do to these factors? I had to set each one equal to 0 so that I could then solve them. And yes, I would subtract the 8 on the first one. So x equals negative 8, and then add 8 to the other. Change the sign. That's usually what. Here's the next hard part. When it deals with radicals, you actually have to check your answers. Because even though you can get the answer, doesn't necessarily mean it's the correct answer. And if it's not, it's actually called an extraneous solution, which I believe your homework asks for it if there is one. This is how you check it. Simply take your answer and plug it in for x. And then just have your calculator tell you if it's right or wrong. So do square root. Instead of an x, I'm going to plug in my first one. So I'm going to plug in negative 8 squared. Again, remember when we plug in, we use parentheses. So I want that square to apply to the entire number, minus 48. What's that give you? 4. Perfect. So that one is a good. Yes. Correct. You want to type it just like that. Now, here's something on your calculator you may not know. Once you've typed this in, if you hit the up button until you have this highlighted, now hit enter. Did it just copy it for you? Oh, it gave you the answer too? Oh, okay. Hit the up button until you have the equation you just typed. Yeah, then hit enter. And it copied it for you, right? Perfect. So now when you have to check the other answer, you just copied and paste this equation. So now just go change that negative to a positive. And then now all you have to do is use the arrows and go delete that negative. Now you already have it. Use the arrow keys. Yeah. Oh, gotcha. Oh, it's gonna be that button. Yeah, so there you go. So that's like that. Yep, and it should get 4 as well. I wonder if I can write from here. Oh, there's a lag. I don't like it. It's like way off too. Like I got to write here. My pencil's way over there. But yeah, perfect. But you do have to check those. So in this case, -8 and 8 are the answer. Yes, I am. This sitting down thing is not my style, but I want it to be recorded as well, so that y'all could go back to it for some that were just discovering it. I do want to do one more and then we'll call it a night. I know we might go a little past 8, but I want to give you another glimpse of what your homework's going to look like there. So let's take the square root of y squared plus y minus 1 equals y plus 3. Again, step 1 is to isolate the radical. Radicals by itself, that's great. Step 2, how do I get rid of that radical? Good. All right, it does. So I'm going to square it. But notice I put the parentheses around this entire y plus 3. So the whole thing on the right side will also get squared. So this will, oh, yeah, it's y squared. Yes, sorry. Oh, so I'm trying to solve for y. So I want, now that I have it by itself, I want to get rid of the square root. So to get rid of the square root, I'm going to square it. But if I square it to get rid of it, I also have to square the right side as well. So now I'm just left with y squared plus y minus 1. Here's where students will also make a mistake, just like always. They're going to try to distribute this square. That's incorrect. They'll try to distribute this square. Yep, and you cannot do that with a binomial. This is y plus 3 times y plus 3. And now you can either FOIL or box method. Y times y. Very good. Y times 3. 3 times y. 3 times 3. Let's combine these guys right here. So then I have y squared plus, what's 3y plus 3y? 6y, good. Not 6y squared, just 6y plus 9. Now to solve this, I have to set it equal to 0. Totally up to you on which side you want to move. You want to move the left to the right or right to the left? I would say left to the right because the numbers are smaller, so there won't be so many negatives. I want to subtract the y squared, but then I'm going to line it up with this one. So I'll subtract that y squared there. And it'll actually cancel these out. I'm going to subtract this y. And then I'm going to line it up with the other y. Because if I'm subtracting y on this side, I have to subtract it over here. This one will cancel. Now, what's the opposite of a -1 here? So I want to actually plus 1 here. And I have to plus 1 here. What I do to one, I have to do the other. So that will go away. So now the left side is a 0. But now when I come over here, 6y plus or 6y minus y is 5y, and 9 plus 1 is 10. Now this is just a regular linear equation that we saw in chapter 9. So how do I solve this? Subtract 10 from both sides. Perfect. You're going to do a lot of work, but you still have to go check it. And that's going to be what gets a lot of students. So this becomes -2 squared plus -2 minus 1. And then you would have -2 plus 3. And all I did was go back and replace all those y's with a -2. And now you'll type in the left side, type in the right side, and see if you get the same answer. Make sure you use parentheses. That's going to be a kicker there. This was 1. All right, what's -2 plus 3? All right, does 1 equal 1? Perfect, there's your answer. And then the last two parts of this chapter was complex numbers. So I'll have some videos for that as well. And I'll have another video with more examples on this one to help you out in homework. That's all I got for y'all tonight. Absolutely.